Okay, good morning, guys. Now that you all know how to write a chemical equation and balance them, I want to spend the last part of this chapter unit learning how to classify the different types of chemical reactions. Now, in chemistry, there are 5 major types of chemical reactions. So today I want to just discuss 2 of them, but we're going to list all of them right here. So the first one's called synthesis or combination, which is when 2 things combine to form one. A decomposition reaction, which is the opposite of a synthesis reaction, where one thing breaks apart into 2 or more things. A single replacement reaction, which is sometimes called single displacement reaction. Those 2 words are interchangeable. Single replacement, single displacement. So where one element replaces a different element in a compound. Okay, a double replacement, or also could be called a double displacement reaction, is where 2 elements in 2 separate compounds kind of switch places. Okay, and then finally is combustion, which you guys generally call burning. So anything you guys can think of that burns, like wood or paper or gas, gasoline, that's a combustion reaction. Okay, now today I just want to go over the first 2 and give you some examples of them. But you'll see these are very simple to identify. Okay, so first, definition. Synthesis or combination reaction is a chemical change in which 2 or more substances react and they form one new substance. So you're always starting with 2. You could start with more, but in our examples, we're always going to have 2 substances. They're generally going to be elements, and they're going to just join together and form one single new substance, which is going to be a compound. Okay, so the general format of these reactions is A plus B turns into AB. So A and B represent generally 2 separate elements, and AB represents a compound made between those 2 elements. Okay, so again, the reactants are generally 2 elements. They're not always, like sometimes you'll see water or carbon dioxide or something as one of those A or B, but in most cases, they're just 2 separate elements. Now, the product is always a single compound, just one compound. Remember, compounds have 2 or more different elements chemically joined together. Okay, let's look at some examples. This carbon combines with oxygen gas to produce carbon dioxide. Okay, so the equation is C, which is carbon, plus, which means react, O2, which remember, oxygen gas is one of those divalent compounds, or elements, I should say, like oxygen, chlorine, fluorine, bromine, hydrogen, nitrogen. Those are the ones that have a 2 next to them, because there's 2 of them in the element. Okay, and then they form carbon dioxide, which is CO2. Okay, so if you were going to, you don't need to actually draw this out in your notes, but if you were going to watch what happens with the carbon and the oxygen molecule breaks apart and the carbon gets joined in between to form that new molecule, CO2. Okay, magnesium reacts with oxygen gas to form magnesium oxide. So you guys have done this reaction multiple times this year. So Mg is magnesium, reacts with O2, which is oxygen, to form MgO. Now, I want you to notice I have already balanced it for you. I'm assuming at this point in this chapter, this year, you guys can balance chemical equations. So you need to put the 2 in front of the MgO to make sure you have 2 oxygens on both sides. And then because you did that, you have to put a 2 on the left-hand side in front of the magnesium to balance that element out. Okay, and then the last example, calcium oxide reacts with water to form calcium hydroxide. Okay, so this time I want you to note we have 2 compounds reacting to form one compound. So I told you they're generally 2 separate elements, and they generally are, but sometimes you have compounds, and this is an example of that. So CaO plus H2O produces CaOH2. Okay, and then if you guys want, there's a chemical reaction video on iron and sulfur reacting to form iron sulfide. Okay, then last thing I want to do today is decomposition reaction. It's just the exact opposite of the synthesis reactions. So decomposition reactions are where a chemical change in which a single compound breaks into 2 or more simpler products. Now, remember I told you in the last synthesis reactions, the 2 reactants are generally elements? Well, in this case, the 2 products are generally elements. Again, there are exceptions to that, but generally they turn into elements. Okay, so the general format is AB, which is a compound, breaks apart into A and B, which are generally 2 elements. Okay, so a single binary compound. A binary compound means it has 2 different elements in it, like NaCl, salt, or sometimes we're going to see that AB is going to be a compound that has a polyatomic ion in it, like hydroxide, OH, and those can break down in multiple different ways. Now, the products, as I said again, are generally two elements, but not necessarily. Okay, so let's just look at 3 examples and we'll be done. Okay, so sodium chloride of salt decomposes into sodium and chlorine gas. Okay, so first, I wrote the equation out there. So we have NaCl breaks apart into Na and Cl2. And then again, I already balanced it for you. I had to put the 2 on the left-hand side in front of the NaCl to make sure my chlorines were balanced, which then means I need to put a 2 in front of the Na on the right. Okay, so if you were going to visualize this with atoms, this is what would be happening. The 2 salt compounds would be breaking apart into 2 separate sodium atoms and 1 chlorine molecule. Okay, now let's look at mercury 2 oxide decomposes when heated to produce mercury and oxygen gas. Okay, so this time I'm going to look at the elements first, or the atoms. So you see the 2 compounds on the left-hand side. When we get to the right-hand side, they break apart. You have 2 separate mercury atoms and then 1 oxygen molecule. So when you write that out, 2HGO breaks apart into 2Hg plus O2. So 1 compound breaks into 2 elements. And there's a video there if you guys want to watch it, just to kind of show you what this reaction looks like. Okay, and then last one, hydrogen peroxide decomposes into water and oxygen gas. So anytime you guys have ever put hydrogen peroxide on your skin, like if you had a cut and you saw it starting to bubble, this is what was happening. The enzymes in your blood were actually breaking apart the peroxide, and you were making some water, which you don't see because it mixes in with your blood, but you see some bubbles. Those bubbles are oxygen gas. So the formula is 2H2O2, which is 2 hydrogen peroxide molecules, breaks apart into 2 water, so 2H2O, and 1 oxygen gas. And if you look at the bottom of the screen, you can see the actual molecules, kind of what happens here from starting products or starting reactants to final products. Okay, there are 3 more types of reactions which we will cover next week. So that's all for today. There are no review questions.